used include the thermal protection tiles, the reinforced carbon-carbon of the nose and wing leading edges, which were looked at using the orbiter boom sensor system on Flight Day 2, and the landing gear doors in the Elevon Cove. These photos that Williams and Kotov take will be downlinked to Mission Control, where engineers will be able to assess and analyze them to provide an assessment of the health or condition of Endeavour's heat shield. When Endeavour completes its backflip, Zamco will fly the shuttle through a quarter circle to a position about 400 feet directly in front of the station, and that from that point he'll begin the approach towards the pressurized mating adapter number 2 on the forward end of the Harmony node. We're continuing to watch views from video cameras on the outside of the International Space Station, which have been watching the Space Shuttle Endeavour as it approaches the station. The rendezvous radar information on board Endeavour is indicating that the vehicle is 39,000 feet away from the station, or about a little more than 7 statute miles. For the final phase of docking, Endeavour's commander, George Zamco, will line up the docking ports of the 2 spacecraft using a view through a video camera.
SOR activation step 3 in work. We copy, Endeavour.
There's a video camera mounted in the center of the orbiter docking system that will provide that view for Commander George Zamco to line up Endeavour's docking port with the International Space Station. This is a view from that camera, a snapshot view from that position in the center of the orbiter docking system. At a point about 30 feet from the station, Zamco can pause to ensure proper alignment of the 2 docking mechanisms. And he will move Endeavour in, maintaining the shuttle speed relative to the station at about 1/10 of a foot per second, while both Endeavour and the station are moving at about 17,500 miles per hour in orbit. The goal is for Zamco to keep the docking mechanisms aligned to within a tolerance of 3 inches. When Endeavour makes contact with the station, preliminary latches will automatically attach the 2 spacecraft. The shuttle's steering jets will be deactivated to reduce the forces acting at the docking interface, and shock absorber springs in the docking mechanism will dampen any relative motion between the shuttle and the station. Once that motion has been stopped, the docking ring will be retracted to close a final set of latches between the 2 vehicles.